Yeah, last but not least, Atle Harby, again from SINTEF. And I'm looking forward to an interesting talk about sustainable hydropower.
Yeah, I was supposed to talk about methods, solutions, and indicators for sustainable hydropower. I will do that, but very briefly, and I will add some reflections I have, I think. I will take the chance to talk a little bit wider than I wrote in the abstract. Just to get right onto it, one of the things we have been working on in Norway for a while now is to develop a method to categorize hydromorphology. And what is hydromorphology? Well, I believe all of you might know that, but I think it's very important when we communicate to the rest of the world, those who are not specialists, that we explain, because hydromorphology is not a very common word in common language, right? But it's all about flow, riverbed, riparian zone, flood zone, and these things people can understand. So please talk about it like that as well. And it's about the water velocity, depth, turbulence, substrate, physical habitat, riverbanks, where animals are living in the water, etc. And this is actually also what is directly impacted by hydropower. So that's why we have to focus on these things. So, of course, it's hydrology, which can change, and flow variation, they change naturally in time, and of course that is impacted always by hydropower. How can we categorize that? I think it's more than 150 different metrics, or maybe 200. I think we have a spreadsheet of 180 different ways of categorizing how hydrology is changed. We don't need all of them, but we have to think about variation in hydrology and how is that after hydropower compared to what it was before. And on geomorphology, there's also quite a lot of different ways of characterizing that. So we have to choose some, and that's what we did in this development of a Norwegian system for a proposal for how to classify hydromorphology. And then I have to remind you about a couple of dilemmas for the Water Framework Directive. Hydromorphology is regarded as a supporting element. Just like this, it's supporting a building, right? But it's also fundamental. It means also fundamental. So if you talk to English-speaking people about support, in Norway it's looked at sometimes as a side activity, a side thing, but it's actually the fundamental thing. And if you think about a river as a house, and the animals living there, the river is the house, and it needs a good fundament, and the fundament is the hydromorphology. It's quite simple. A river without water, there will be no aquatic life. So we need a fundament. That's the hydrology and the morphology. So it's totally fundamental for the ecosystem that you have hydromorphology. And I'm very little bit disappointed about the Water Framework Directive, which kind of regards this as almost a side activity. It just cannot be overlooked. It has to be always included. What is the fundamental parts of a river and an ecosystem? It is the hydromorphology. Another challenge, which I believe already has been addressed yesterday, is that water is, of course, flowing from the mountains to the sea, from source to sea, and it's sometimes difficult to split it into units, as you have to do. We always have to do that. Researchers also do that. When we study things, we cannot always have the full picture. Like Mauro talked about, we can look at barriers, but we are in a very local scale, but we also need to look at in a total scale. So this is a challenge. It's difficult, and we have to keep this in mind that things are connected in a river. Okay, that was my dilemmas about the Water Framework Directive. However, we have developed a suggestion for the authorities to take further about how to characterize hydromorphology. We ended up with something like 20 different indicators described in a report, which then can be used and either used as it is or developed further by the authorities. I was planning to talk about how that can be implemented and give some examples, but I will skip that. You can talk to me about it later, and rather move on to the other part of my talk, which was supposed to be about this environmental design method. This is something that we have to use, we propose to use to take into account both ecology, hydrology, and hydropower development. Basically used in Norway for existing hydropower, how to make them better, how to make them more sustainable, And it's very important that we have all the topics included in an assessment. The way it has been described is also now in a handbook. It's a method that is not actually a lot of new things, but it's a systematic approach put together in tables, as you see an example of here. There's also developed a handbook only for salmon, which is the highest interest in Norway so far. And there is a course as well. And this actually handbook, as you may know and have seen here earlier, you also seen examples. I think actually some of the topics Oda showed yesterday, some of the examples this method have been used to design when you have to do impacts on a river to make the ecosystem function better. Yeah. So it's more or less about finding bottlenecks and actually the worst, let's say, what is the highest impact? What have you done to your river? And to mitigate that. And then I always say, please remember that fish only dies once. So if you have a river course like this with no fish but sheep in the river, then there might be a little bit difficult for the fish to survive. Yeah. Another part of this method is also to look at how to design how to use the water. Just like you saw in the last talk, that it may be, we maybe should look at that in a different way. When and how is water needed, right? So maybe we can adapt something that actually not necessarily mimics, but follows and represent the natural processes that the flow is giving to the river for moving substrate, for rearranging the habitats and so on. Not every day, but at least when it's necessary. Not every year, sorry, when it's necessary, right? So think about that. And we also propose a lot of other mitigation measures. You saw a very good talk yesterday about also the costs of doing some of these things, which Ulrich presented. So it's all about if you cannot actually always release the amount of flow that was there naturally, you have to try to do things to represent what the river would have done naturally itself, which may be flow releases, ensure a stable ice cover in those rivers that used to have that. Maybe do this thing that we call a river in the river. When you have a very wide river, which you take away a lot of flow, maybe it's better to construct something that gives an impression of or reduces the wetted area, but actually keeps some of the hydraulic dynamics in there with pools and riffles. Of course, two-way migration solutions needs to be there, and this thing with improving habitats, for instance, spawning habitat with using gravel. And a quite interesting thing we have introduced, and I think it's in practice in a couple of rivers in Norway, a water bank, which is to be used in special cases when there is too little water for the river. You can use water from the reservoir, a water bank for environmental purposes. Yeah. Okay. Am I halfway now, Brenda? More or less? Yeah. So I will not show an example of this, how this has been used neither. We saw, you may have, yeah, you saw a little bit of that yesterday, but you can have a talk to me if you want to know how it's used. I think there is also some handbooks out there in the hallway. So, yeah, now we are actually developing this concept further to take into account a much wider perspective than just this handbook for salmon. Other species and habitats, we are looking at flood protection, we are looking at also energy services. I mean, it's not only about kilowatt hours, it's also about flexibility. And we include also recreation and tourism, and offers also a view on different methods and tools that can be used to in a study where you want to apply environmental design. Now I'm talking about something totally different. How many have heard about Dunkelflaute? I guess the Germans in the audience know this. Yeah. Yeah. I hope I'm right if I say what it means. Dunkel means dark, and Flaute means no wind. So it's a situation, well, it says on the screen as well, it's a situation with hardly no wind nor solar power. This is the very scary things for those countries that develop a lot of renewable energy from wind and solar and do not have the hydropower. So what do you do when there is no wind and no sun? And what do you do perhaps when it's too much of wind and sun. And this will happen. It happens today. There are episodes already today in continental Europe where you have no wind and no solar. Today, thermal production replaces that. In the future, when there is no more thermal production, what will we do then? And when you see there is also been periods with negative electricity prices, that's a reflection of you have surplus. You have too much energy on the grid, so people are paid to consume, which may be not a very sustainable way of running a system, right? So we have studied, and this is what I would like you to focus on, wind production in the North Sea area, the whole North Sea area in 2030. We used wind data and superimposed all the wind power offshore and onshore that will be there. Europe is on track to do this, so there will be 90,000 megawatts of wind power. And this graph in blue shows the production, and I just took the average, and you can see from an hourly data from 1 week, there is almost maximum production, and a little bit later, there is 7 days with almost no production. And if you want to replace that energy, assuming that on average we will need this red line, if you want to replace that energy, it's about 1,000 typical pump storage plants. You need to build 1,000 new ones, 1,000 pump storage plants that you have in Europe today, 1,000 of them. And I don't think that's feasible. Some people talk about batteries. We can use batteries. Well, you may have heard of Elon Musk's battery project in Australia, the Hornsdale Power Reserve. You have to build almost 40,000 of those just to replace this energy in the North Sea, right? Is that feasible? What's the impact of that? I don't think it's possible, right? But hydropower can do the job. We looked at this in Norway, the pairs of reservoirs that are there. It's possible to use existing reservoirs and install just parallel power plants to those we have today, 20,000 extra, with hardly any other environmental impacts than you will have a different pattern in how we regulate your lakes. And you will, of course, have to build more transmission lines. But you don't have to build any new reservoirs, and the power plants, they will be in parallel to what they have. So we have the part of the infrastructure there, so it's maybe not such a bad idea. But you will need, of course, more interconnectors to continental Europe to be able to balance this wind power that you will lose. We studied this. What is actually the impact of doing that? And we moderated a little bit. We actually added something like 11.5 gigawatt, not 20 gigawatt of extra capacity in Norwegian power. And you know what? And then we looked at the whole European system. It's a large energy simulation study. And it showed actually that if we do that, this 11 gigawatt of extra capacity in Norway replace the need to invest in 70 gigawatt of solar, hydrogen, and batteries power in Europe. So 11 gigawatt replaces 70. You don't have to invest in all that solar power, mostly in Germany actually, if you can do this balancing act. Quite interesting. So, a little bit about sustainability. Of course, we need hydropower to give energy for all, to also help both several other sustainable development targets. But how does this look when we have all this crisis coming on top of us? Of course, we have the pandemic, we have the climate change, we have a biodiversity and a nature biodiversity crisis. And beware, there's a lot of reports out there now, and not much is happening. But I think we heard a little bit about the EU taxonomy, and everything that comes now from the finance sector will have an impact. Of those here that are hydropower producers, you already have started to report to the taxonomy. You may also start reporting to the Task Force for Climate-Related Financial Disclosures, and you should also learn Task Force for Nature-Related Financial Disclosures. The finance people, they don't want to invest in things that has a high risk, either of being impacted by climate change or being impacted by loss of nature. So this is coming, and the finance sector is driving that, and they will require knowledge. So all companies of a certain size will have to declare what is their impact on nature and what is their dependency on nature, and what is have they actually assessed the risk of their coming regulations that will make it harder for them, for instance, protected areas, whatever regulation that comes, will make it harder to do their business. This is what the finance sector want to know before they put the money somewhere. So beware of that. And I think that's very good. And I think we should jump on that train and start preparing for these things. Of course, you know that hydropower has many environmental and social impacts. I'm not going to talk about that. I think you know that already. And I think also we all agree that we have to protect some areas. If you look at this map, this picture here, it's actually a perfect site for hydropower. You have a lot of runoff from the glacier. You have already the reservoir, and it's directed to the fjord, right? But if you see that Norwegian map, the dark green areas are those today that is left of pristine areas. So we should not actually go into those areas, to my opinion. Maybe we just have to keep some undisturbed from nature, even if it's perfect for hydropower, right? I think most of you agree on that. So, to wrap up, actually my message, what is sustainable hydropower? Well, we need to have all these things delivered from hydropower, like energy and also clean water. It will help to avoid zero hunger and economic growth. All these things is in the sustainability development goals, right? And what is sustainable hydropower then? I think that's the wrong question to ask, because we cannot see hydropower isolated from the water and not from the society. So I think that sustainable hydropower, we should rather look at that will be in hydropower that provides energy and water management for all users and interest, and also contributes to welfare. This is more in line with the development goals, and I think hydropower alone is a little bit too isolated to see, because it's in the catchment, it's in all the services, the ecosystem services, the goods to the people that the river gives to us. We have to look at that, not only the hydropower. And then just a little reflection to finalize. What is then a sustainable energy system? What is the alternative? We talk too little about the alternatives. You see the picture of the alternative here. It is fossil fuels, right? So we cannot really... of course, we can do more efficient energy generation. We can stop using... We could use fossil fuels instead of hydropower, but I don't think that's viable. We can make things more efficient, and we can use less energy, but we need more electricity to get rid of those things that doesn't run on electricity today. So what is the alternative? And I miss that in the debate. If we don't develop hydropower, what will we develop then? Or is there better alternatives? And in some cases it is, but we have to look at that, I think, to make it a sustainable choice. So I think the holistic view that we maximize reduction of CO2 emissions, that we maximize the benefit for society, and we have to include the effects of not doing anything, because that's what's happening today. We're not doing anything. We just have more of that fossil fuels, right? That's the alternative today. I'm not saying that we should build down all nature to get rid of this, but we have to think about that. And for every day we do nothing, it's more and more of the CO2 to the atmosphere, and it's not only CO2, it's a lot of other bad things connected to fossil fuels, right? So please think about that. And of course, we have to minimize the impact on nature. Perhaps we can become nature positive. We have to restore something as well. That's my last message. Think about becoming nature positive. Thank you.